Here's problems 2 and 4 from the from section 4.1, and in both of them they ask what are the extreme values and where do they occur. Let's focus on problem number 2 first, and let's say is there any absolute maxes in problem number 2? Well, because this is open, we try to get closer and closer to this, but every time I try to select a point and call it the absolute max, I can get a little closer to that open point. And if I choose another point, I can get closer and closer and closer. So there are no absolute maxes in this drawing because I can never declare the value that's highest above here. Similarly, there's no absolute mins in this problem either. Because as I try to get closer and closer to this point, I can't get close enough. I can't get further enough down, and every time I try to declare a point to be the one that is lowest in the graph, I can always get a little bit lower. When it comes to this point, though, at -1, 0, that is a local minimum, because I can create a half-closed interval in which that point is the lowest within that interval. Likewise, at 1, 0, there is a local max, because again I create a half-closed interval, and this point here is the highest value in that particular in that interval. Moving on to problem number 4, we could say that there's the absolute maximum for this is 2, and that it's at 1, 2. As for absolute minimums, the absolute minimum is -1, and it's found at 0, -1. By the way, those absolute maxes and mins are also local maxes and local min. Our endpoints are both have local maxes and mins, so that we could say there's a local, in this case, a local max at -3, 0, and then likewise there is a local min at this spot, which is 2, 0.